Hey guys, my name's Nate. I'm the founder of TokenDynamics. I'm going to be speaking to you about privacy protocols and the opportunities for them to introduce tokens in novel ways and the unique advantages that privacy protocols and privacy preserving protocols have regarding tokenomics and token utility and all sorts of things that I'll talk about today. So, and by the way, TokenDynamics is a protocol design firm with an emphasis on value accrual to a token and economic security, which is the alignment of incentives in a protocol. So firstly, I'd like to give you a background on what is tokenomics. So you guys have probably seen this pie chart over here or something like it that describes the allocation, essentially a cap table of where tokens go and who gets tokens. And this is important, but ultimately less consequential than what the token is used for. So I'm going to focus on that today. But to recap quickly, this is sort of the supply side of tokenomics. It's what is the allocation to who, how is it distributed, and how much supply is there, things like that. It's mostly concerned with artificial scarcity to reduce the token price. And historically, this has been the focus of a lot of projects who are trying to pump and dump their token to inflate the valuation. And you can contrast that with demand side of tokenomics. So I created this term in 2021 called demand side tokenomics. This is maximizing a token's value through its use in the protocol or by giving it some kind of utility. And I'll speak about the different types of utility there are today. But generally, tokenomics is the study of how a token behaves and accrues value and are the ways that a token circulate in an economy that cause it to accrue value. So these are the three principles that over the last 8 years of writing about this and studying this, I identified that all tokens need to include to optimize for the trade-offs in their protocol between the various groups of users. These are protocol utility. That's like the value created by the protocol rather than the token. Then there's value accrual. This is the usefulness of the token that tends to translate into the minimum possible price that it can hold. I may speak about price floors a little bit today, spoken at length about it in other talks. And the third principle is economic security. So this is the alignment of incentives in a protocol. And I'll talk a little bit about that later. So these three principles actually form a trilemma. And so in any design decision, any protocol design that you're doing, you're going to find that these three things pop up, and you're optimizing between these three principles that makes it a trilemma. And they map to the interests of users, investors, and the protocol itself and its own security and longevity. So the Tokenomics Trilemma, I'll give a few examples of. The best example that I can find that I've been using for the last 4 years is Uniswap and their decision to turn the fee switch on. This is the fifth time. It came up like last week, and they were talking about it more from the legal perspective of whether it's legal to distribute, give out dividends, or do some kind of token reward distribution. But historically, their challenge has been optimizing between the interests of users and investors. Do we turn the fee switch on and take from LPs and take away from their returns? Or do we make it more expensive to swap tokens through Uniswap by charging a fee and then paying that out to the token holders? So this is an example of the trade-off between protocol utility and value accrual. You guys are probably familiar with Terra. How many of you were around for the Terra collapse? Okay, I see a bunch of hands. So Terra, for those of you that weren't there, was a highly leveraged token that was placed at the center of this protocol. People were building stablecoins around it. They were doing lots of different things with this token, and that caused a lot of token price dependencies, which compromised the economic security of a protocol when done wrong. And so Terra was an example of a trade-off between value accrual. Terra reached the top 10, might have gotten up to 5 or 6. It was one of the hottest tokens of the early DeFi, first DeFi run. And when it collapsed in 2022, wiped out billions of dollars of value. And that was for a failure to properly optimize between value accrual and economic security, the interests of token holders, investors, and the protocol itself. And then an example of the trade-offs between protocol utility and economic security, the users and the protocol itself, often arises in capital efficiency, where capital efficiency is a concern. So we see this in Bitcoin. They're unsure of how to subsidize the security of the network because they don't want to charge users more. Users, as we saw in 2017 and the ensuing bull runs, users tend to disappear when the fees get too high. They use a different blockchain. And we also had another example of this recently with Stream Finance. So they were looping what we would call in traditional finance rehypothecating collateral, but we call in DeFi looping when an individual does it. They were looping to get higher yield. And that is ultimately a consideration of capital efficiency. And so there are a few different types of tokenomic mechanisms. There are broad categories of mechanisms that you can include in a protocol to cause a token to accrue value on purpose. And they map pretty well to the different asset classes from traditional finance. There are currency-like, equity-like, and commodity-like mechanisms. And you can see them decreasing in their value accrual properties and also in the amount of friction. So to be more concrete, the currency-like mechanisms are going to accrue more value to a token, but they're going to create more user friction. So if you insert an arbitrary token at the center of your protocol, let's say you're a privacy protocol, and you create your own token that people have to use if they want to use your protocol, let's say they're denominating all of their inputs to a privacy protocol, like Tornado Cash, in a unique token. Maybe that's $10,000 worth of X tokens that go in. You're going to accrue a lot of value to that token because people are going to be forced to buy it in order to get the utility your protocol provides. But that creates a lot more friction for the end user. Commodity-like tokens we don't see too often, but something like a Pac-Man token for using your protocol, you could call a commodity token. And this is a little less user friction, but it's still kind of a pain for people to use it, which is why a lot of people opt for equity-like tokenomic mechanisms, including buyback and burn schemes or treasury distributions that where the token represents ownership of some part of the treasury itself. And so we have a challenge in privacy protocols in particular that, where we want to introduce a token with little friction that accrues value and doesn't compromise the protocol, that adequately solves for these three things. And I've mapped a few here that have solved these problems in different ways or tried to optimize, but maybe missed a component. So on the left, we've got Tornado Cash, which introduced its token as a pure governance token, had some claims to the treasury, but had arbitrary logic in what the governance could do, and that ultimately destroyed the protocol. They were exploited because of the range of things that the token was able to control in the protocol. Ultimately, that included minting many more of these tokens to the attacker, and collapsed the protocol or siphoned a lot of value from it. On the right, so that's an example of a protocol that maybe had utility and value accrual, but at the cost of economic security. On the right, this is the logo for Fern Protocol. They were an excellent, really beautiful cryptographic protocol that was a privacy protocol, and but they weren't improving an order of magnitude on competitors. They weren't so much far above competitors that they were able to attract deposits. And so they had a pretty good value accrual mechanism or a good enough value accrual mechanism, and they were economically secure as a non-upgradable protocol, but it was lacking some utility compared to competitors. So when users are doing this optimization in their heads, they're thinking, I might as well use a different privacy protocol that maybe has other cryptography or a smaller anonymity set, but it is at least better for my needs. And then Railgun, the third consideration, was an earlier privacy protocol that opted for an equity-like distribution. And I put them on the edge there because they've got pretty good value accrual, but there are some concerns around liquidity and ultimately the long-term value accrual properties of the token. And in the middle there could be you and your protocol. So solving the trilemma involves, I'm going to walk you through a little bit of our process at TokenDynamics of how we think of this. First, we look at who are the user groups in a protocol. What groups of users are there? Who are the distinct users? And what are their interests? Like, what do they want to use a protocol for? So you have some groups of users that want to use privacy because they want larger anonymity set. And so that may beg the question, how do we get a larger anonymity set? And we think of protocols at TokenDynamics as multi-party transactions where you're optimizing not between Alice and Bob, but maybe between Alice and Bob and Charlie. So if Alice has milk, Bob has eggs, and Charlie has chickens, but they all want one of the others, our challenge becomes, can we build a mechanism that facilitates this 3 or 4 or 5-way trade and also accrues value to a token in the process by inserting the token in the middle of that transaction somewhere, either as a currency with a currency-like mechanism, an equity-like mechanism, or a commodity-like mechanism. And so ultimately, this is going to look something like evaluating the utility and the value propositions of blockchains. So there are a few, right? There's self-sovereignty. Users of privacy protocols want to hold their assets. Blockchains are also good for programmability and censorship resistance. And so when we're thinking about how to design mechanisms to accrue value to a token through a novel protocol, we're thinking, how do we leverage the unique value propositions of blockchains in order to do this? So, off the top of my head, it might be something like incentivizing anonymity sets by paying out yield, because users are sometimes interested in yield, and then you have to ask, where does the yield come from? So it might be from the other users that aren't staying in the anonymity set as long, or from a form of staking where you have an opt-in interface to allow users to stake their assets before they go into a privacy pool and put them to work. There are all sorts of things that blockchains can do because they're programmable that also leverage censorship resistance and configurable transparency and all of these other value propositions of blockchains. And so at TokenDynamics, when we're thinking about designing these things, we're generally visualizing it as a multi-party transaction, inserting a token in a way that makes sense, doesn't cause too much friction, and then seeing the market do the work to increase the token price and put buy pressure there, rather than relying on speculation. And so we've got a couple questions, couple minutes for questions if you guys would like. But otherwise, thanks for coming to my talk, and you guys can find us on Twitter, my Twitter at Satori Nakamoto, and also TokenDynamics. All the links are here at the QR code. Thank you, guys.